Good morning, ma'am. This is SN Mushkina Banu from CSC branch C section, studying second BTech first semester. My topic for CAA-2 assignment is de-multiplexers. De-multiplexers. In this slide, we are going to discuss in the contents of the topic de-multiplexers. Firstly, introduction to demultiplexers, basic operation, demultiplexer structure, truth table, types of demultiplexers, design considerations, advantages and limitations. Let us give a brief introduction to demultiplexers. A demultiplexer is a combinational logic circuit that converts a single input single into multiple output signals. It allows control over the routing of data signals to different destinations. Demultiplexers play a crucial role in digital circuits and systems for data distribution. The basic operations of demultiplexers are: the primary function of a demultiplexer is to select one of many outputs based on selected lines. It takes one input and distributes it to one of several outputs according to the select line values. This ensures that only one output line is activated at any given time based on the input and selected lines. Let us explain the structure of a demultiplexer. A typical demultiplexer consists of a single input and multiple outputs and selected lines. The number of outputs is determined by the number of selected lines for n select lines. There can be 2 power n outputs. The basic logic gates used in constructing a demultiplexer include AND, NOT, and OR gates. This is the structure of a demultiplexer. Truth table for a demultiplexer. It illustrates the relationship between the input selected lines and output. Each combination of selected lines corresponds to one output being activated while others remaining low. This table helps in understanding the functioning and designing of a demultiplexer. In this slide, we have truth table for 1:2 demultiplexer. In this, the selected is 0 and input is 0 and both outputs y1 and y2 are gives zeros. The second line, the selected line is 0 and input which we give is 1 and outputs for y1 is 1 and y2 is 0. In third step, selected line is 1 and input which we give is 0 and outputs y1 and y2 both gives 0. In the last step, we selected lines are 1, the output which we give is 1, so the output for y1 is 0 and y2 is 1. Types of demultiplexer. Demultiplexers can be classified into three types. They are 1:2, 1:4 and 1:8. These are classified based on the number of outputs they support. The most common types are the 1:2, 1:4 and 1:8 demultiplexers used for various applications. Each type has a different number of selected lines and output configuration. Let us discuss design considerations. When designing a demultiplexer, one must consider the number of outputs required and the select lines configuration. Performance factors such as speed, power consumption, and logic family compatibility are crucial. The layout of the circuit should minimize propagation delays and crosstalk between outputs. Advantages of demultiplexers. Demultiplexers simplify the design of complex digital systems by allowing multiple outputs from a single input. They enhance data routing efficiency by minimizing the number of required connections. Using a demultiplexer can lead to reduced circuit complexity and cost in system design. We have done with advantages of demultiplexer. Let us discuss limitations of demultiplexers in this slide. One limitation of demultiplexer is that they can introduce delays in signal transmission. If not designed properly, they may also face issues like crosstalk and signal degradation. Scalability can become a challenge as the number of outputs and select lines increases. From the below slides, we can conclude that demultiplexers are essential components in digital electronics that enable efficient data routing and distribution. A clear understanding of the operation, types, and application is vital for digital circuit design. As technology advances, the role of demultiplexers continues to evolve, making them increasingly important in modern systems. Thank you for giving me this opportunity. Have a nice day.